So for this problem, we'll need to look at the mean and standard deviation. We're going to use a mean of 3.7 and a standard deviation of 1.2. The first question asks us to find the probability that x is less than 4. So if we were to sketch our distribution, we know that it has a mean of 3.7, so 4 is going to be something above that, maybe here. And we want the less than, so we want this side. Okay. This is currently in x's, and so there's two approaches you can do. So if you want to use Excel to answer this question, it will help a lot. And there's two different formulas you could use. You could use the norm.s.dist formula, and this is if you have a z, and for this one you would enter in your z value and then the word true. Or if you want to use it in x's, you could use norm.dist. You would have to enter your specific x value that you're finding, your mean, your standard deviation, and then the word true. And this is if you're going from an x. Oops. Come on. Oh. Excuse me. Okay. So if we want to translate this into the z, or the standard normal distribution, which has a mean of 0, we would do that by taking our x value and finding the z. You would take 4 minus 3.74 and divide by 1.2 to get what z you would plug in. So we'll open our calculator and we'll do that calculation. And we get that it is 0.25. Okay. And so if we use this z, that means in Excel, I'm going to use a z of 0.25 in the formula I wrote above. So norm.s.dist, 0.25, true. So we're using the word true here because we're talking about a cumulative distribution, the standard normal to be exact. And so we want everything up to 4, so we'll mark that as true. And it gives us that probability. It's always going to give the left-hand side, but if you go back to our picture, we want the left-hand side probability. So that's going to be the correct one. Now you also could have used this second formula here, which I'm going to do the calculation again. This time I'm going to use my x of 4 that's given in the problem, the mean and the standard deviation of the specific normal distribution in the question. So I'll show you this formula so you can see the one I started with. Or if you use just what you have in the question, you would have your x that you're finding of 4, your mean of 3.7, and your standard deviation 1.2, still using true. And you see we get the exact same number. So those are the two different formulas you can use in Excel to find probabilities in the normal distributions. You can either convert to the standard normal and use the standard normal one, or you can leave it as is and do the other. Now we want to find the probability that x is between 4 and 6. So if we sketch out our picture, again 3.7 is in the middle, so 4 is just a little above that, and 6 is above that. So we want this middle range here. From A, we already know what this piece is down here. That was what we found in Excel. So we need to find this part. So we need to find the probability x is less than 6. So again, you could convert the 6 to a z and go from there, or you could just cut out the middleman and go straight using the norm.dist formula, which is what we're going to do. So switching to Excel, we want to find norm.dist. Now we have an x value of 6, our mean is still 3.7, and our standard deviation is still 1.2. We're still going to use true. So I'll put my formula out here so you can see it. So that means we get 0.9724 when we round to 4 decimal places, as the question asks. So this is 0.9724, and this was 0.59886. And so the difference between the two, we would take that first one, subtract out the second one, and see what we get here for our answer. I'm going to go back to Excel, and I'm going to find that difference. Take that one and subtract that one to get 0.3737 if you round to 4 decimal places. Now, if you ever don't want to round yourself, or you want to double check you did it right, under number in the home ribbon, you can increase and decrease your decimal points, giving us that. To see our answer is 0.3737. Now we want to find the probability that it's greater than 8. So again, we have 3.7 in the middle. 8 is somewhere way up here, and we want greater than. So the first time in this set of questions, we want the right-hand probability. What Excel is going to give us is this part over here. So we'll have to do 1 minus whatever we get to be able to translate it. So it's good to sketch it out before you go to Excel and calculate, just to make sure you're finding what you think you're finding. So switching to Excel, we're doing norm.dist. Our x for this question is 8. Our mean is still 3.7. Our standard deviation is still 1.2, and we still want to get that part. Now it's showing 1 because it's a really high number, but if we were to force the decimals out like I just did, it would get bigger and show us that it's not quite 1, but it's very close. So there's the formula for that. I'm realizing I didn't label these very well. This first one was for A. I showed you both formulas, which is why there's 2 answers. This is for B. But this is our answer. Either of these were the answer for A. And then for C, we don't have our answer yet, because that 0.9998 is the probability that it's less than 8, and we want the probability it's greater than. So we're going to have to do 1 minus the number in order to get our probability. Part D asks you to label any unusual events. So we have here our 3 probabilities from A, B, and C. To be unusual, it must happen less than 5% of the time or have a probability smaller than 0.05. So A, that is not an unlikely event at all. B is not unlikely enough, but C is. So this one is unusual. But the other 2 were not. Now for this problem, we're going to invert the process that we did before. So now, in our normal distribution, it's giving some area, the probability, and we need to find the number that goes down here. So we're going to invert the process and use something called the inverse in Excel. So since this one is in the standard normal distribution, we'll use norm.s, and then for the inverse, .inv. And the only thing you need to enter into Excel is the probability on the left-hand side, which is the probability that it's given you. So let's go to Excel and find it for this question. So we need norm.s.inv of 0.4404, and that's all that we need to enter, and it gives us negative 0.15. So that is the z that corresponds to the area of 0.4404 on our graph. In the future, if you have a normal distribution, you can take out the s, and then it'll just ask you for the mean and standard deviation of the normal distribution, and it'll do the same thing. It'll give you an x value that corresponds to a specific probability. For this question, you're going to be using something called a sampling distribution. So the central limit theorem says if you have a sample size of at least 30, then it doesn't matter what kind of population looks like, whether it's a pretty bell-shaped curve and normally distributed, or whether it's something completely weird looking. You can still use the normal distribution and the standard normal distribution properties to find probabilities of the average. So on average, those sample means will have a nice normal distribution, even if the population doesn't. So now when we're sketching out our probabilities, the thing that has a nice bell-shaped curve is the sample mean. Okay, so this is the sampling distribution, not specific x's. And the sampling distribution has the same mean as the original population, so this is still 64.1, but its standard deviation is different. It's going to be the population standard deviation divided by the square root of the sample size, which in this case is 62. So it's going to be a tighter distribution than just a regular x was, because we're going to have a much smaller standard deviation. Okay, and we want to find the probability that some mean is greater than 65. Well, we know 65 is going to be over 64, so it's there, and we want the greater than half. So that means the number that it spits out in Excel is going to be this number, but we want this right-hand side. So we're going to have to do some adjustments. So we're still going to be using the distribution formula in Excel, norm.dist. For our mean, for our x value, we use the one that we're interested in still, which is 65. For the mean, we still use 64.1. But instead of using 2.77, we need to use 2.77 divided by the square root of 62. Now you can calculate this in a separate cell and type it in, or you can let Excel calculate it as a function of it. I'm going to do the second method just so that it's all in one place. And then we still end with true. So let's head over to Excel and calculate. Again, this is going to give us the less than left-hand part, but we want the right-hand greater than part. So norm.dist of our x value of 65, our mean of 64.1, our standard deviation is 2.77 divided by the square root of 62, not 63, 62, because that's our sample size, and we want true. So in this version of it, we're allowing Excel to calculate the standard deviation, so it's going to have as little rounding numbers errors as possible. So I'll make my formula here where you can see it. I'm going to give one more decimal point. Okay. So the probability that it's 65 or less is 0.9947, but we want greater than. So we need to do 1 minus the probability to get our answer. So the answer to our question is 0.0053. Going Going back to our picture, this was 0.9947, but we wanted the greater than over here, so that was the 0.0053.